Hello everyone, I am Lavanya Vaishnavi. Today I am going to take up the topic operational amplifier. So in this operational amplifier, we are going to discuss about, so first we will go with the introduction of operational amplifier and input modes, operational amplifier parameters. You will be studying about different parameters and the different amplifying techniques, like how do you use the amplifier as inverting amplifier, non-inverting amplifier, summer, voltage follower, integrator, differentiator and comparator. So this is one of the easiest module what you have. You can have an expected list of questions, so you can easily clear the exam. So before going to the actual topic, I want to give a brief idea about what we are going to discuss about this in the upcoming techniques, like upcoming classes. So firstly, so if you like this video, please like it, share with your friends and subscribe to my channel. Yes. Next is topics covered. So which are the topics we are going to cover in this session? The first one is amplification. What is this amplification? Why do you need this amplification? And what is the architecture of OpAmp? What are the advantages and applications of OpAmp? Pin configuration of 741 IC. So it is an integrated circuit that is largely available in the market, so which we use normally. So what is its pin configuration? Next is ideal characteristics. So how should be an ideal OpAmp, a perfect OpAmp, how it should be, that we are going to study here, and operation of an OpAmp. Next, coming to the operational amplifier, let us define operational amplifier before going to this. So going to the actual topic, operational amplifier is an electronic device, so which basically amplifies the differential gain, that is, it takes the difference of input and amplifies it. So for your level, like I'm teaching for the first year, so I'll take that, I'll tell, like in simple terms, if I want to tell, OpAmp is a amplifier device. So amplifier device that strengthens the signal, it will boost the signal in terms of voltage. It will increase its amplitude. So what will be the frequency of this voltages? It will be from few hertz. So you can call it as, we can take as few hertz to several kilohertz. Okay, several kilohertz, few hertz. Say for example 5 hertz, 10 hertz. So from such level of signal to several kilohertz, you can boost the signal. So this is an operational amplifier. Now coming to the architecture of operational amplifier. So what is this operational amplifier and what is the internal structure? So everything has an internal structure, right? Say for example, if you are taking any if you have studied the previous in the previous class, we took okay. So in the previous class, we took an example of rectifiers. In the rectifiers, you had different parts. Like you had bridge rectifier, after that you had filter. In the similar way, here you have different structure, different blocks, after which you get the output. So differential amplifier, or firstly OpAmp, has two inputs. So it has two inputs. Which are the inputs? One is inverting input, the other one is non-inverting input. This is the symbol of OpAmp. This is the symbol of OpAmp. How do you write the symbol of OpAmp? So we write a triangle. To this triangle, so you have two inputs. Okay, one I'll name it as negative, the other one I name it as positive. So this is VCC, plus VCC connection, this is minus VCC connection, and this is your output. Okay, so this is the output V0. Okay, so you have two inputs, this is V1 and this is V2. This is VCC, that is positive voltage for biasing the device, that is for the power supply you give plus VCC here, here you will give minus VEE. Okay, so you can call it as plus VCC and this is minus VEE. The one terminal or the terminal which is given to minus sign is called inverting input, So the other terminal which is given to positive sign is called non-inverting input. It is called as non-inverting input. So the output is V0. So what is this inverting input and non-inverting input? Inverting input means when you give a sinusoidal signal like this, so your output will be inverted like this. Okay. So suppose I give non-inverting input like this. So I'll take the non-inverting input and I'm giving the input like this. So for non-inverting input, you will get the same signal like this. Okay. So this is the difference between inverting input and non-inverting input. This is the symbol of OpAmp. This is the symbol of OpAmp. Okay. Now to this symbol of OpAmp, you can see only a triangular structure. What is there inside this OpAmp? That you are going to see here. That we are going to see here in this blocks. Okay. So it is divided into four major blocks. The first one is differential amplifier. The second one is high gain amplifier. Next is buffer and level shifter. And the next one is driver. Okay. So the first one is differential amplifier. What is differential amplifier? So coming to differential amplifier, as the name indicates, it takes the difference. It takes the difference. Okay. So it will calculate what is the difference. Here if you see V2 is given to plus, V1 is given to minus. Therefore, the difference is V2 minus V1. Okay. So the difference is V2 minus V1. So differential amplifier will take the difference of the input. It will take the difference of the input and again it will amplifies. Amplifies means strengthens. It will boost the voltage in terms of, it boosts the signal in terms of voltage. Next is high gain amplifier. Here amplifier or an ideal amplifier should have infinite gain. That means enormous amount of gain. You should have enormous amount of gain. Okay. So for that I will use one more amplifier stage which we call it as high gain amplifier. As the name indicates, the gain is very high. So what is the meaning of gain? I'll tell you in the next slide, okay, or later. Next is buffer and level shifters. So level shifters, suppose if you want to add some DC level to the signal, say now buffer or level shifter. When I discuss this buffer or level shifter, so suppose buffer and level shifter. So now buffer and level shifters are the devices that shift the DC level of any signal. Next is driver. What is the use of driver? Driver is a device or this is a part of the circuit that makes the output impedance 0 or it minimizes the output impedance. It minimizes the output impedance. For example, here you can use Darlington emitter followers or emitter follower drivers you call it as. So emitter follower drivers, they reduce the impedance. They reduce the impedance. What is impedance? Impedance is nothing but the resistance offered by the circuit for the AC signal, right? So we know that what is impedance. So here we are going to reduce the impedance using emitter follower drivers. So this is about OpAmp architecture. Okay, the next one is OpAmp architecture. Like what is the physical structure? How does an OpAmp look like? So this is an IC. IC is integrated circuit. What is an IC? IC is integrated circuit. So this is an IC. And what IC is it? It is 741 IC. What is it? It is 741 IC. So if you can see, it has a notch. This is called notch. And to this notch, this pin, the first pin towards the notch, like towards the left of the notch is pin number 1. This is 2. This is 3. And this is 4. These are the 4 pins. Okay. And opposite side you will be having another 4 pins, which is 5, 6, 7 and 8. So this is the 8th pin you can see. Okay. So this is the physical structure of notch, physical structure of IC. So if you see an IC, it will be like this. Okay. Now coming to the OpAmp architecture. This is the OpAmp architecture. In this OpAmp architecture, so you can see you have 8 pins. These are the 8 pin representation 1, 2, 3, 4, 5, 6, 7 and 8. So the first one is offset null, like we don't connect it, so we are not using it, and offset null, even Pin number 5 is also offset null. Again, you are not using that pins. So what is offset null, and you're not, like why do we use it? That we will study in the later classes. Next is inverting input, non-inverting input. 2 is inverting input, 3 is non-inverting input, and 4 is power supply minus VCC or minus VEE. We saw in the previous slide, right? VEE minus VEE, that is given to 4, and 6 is output. So if you can see, 6 is given to the output. So this is the output line. You can see this, right? This is the output line which is connected to 6, and 7 is the power supply. So 7 is positive power supply. 8 is not connected. You don't have any connections to 8 because IC will come with the even number of package pins. So pin packages, you will be having 8 pin where it doesn't have any connection here. Okay. So this is how OpAmp look basically. Clear with us? Okay. Let us move on to the next slide. So what is the advantage of OpAmp? Advantages of OpAmp. If you can see the size, it is, if you just see this, you can see the size is very tiny. So it is around 5 millimeter. So 5 millimeter and 3 millimeter, I guess. So that will be the dimension of OpAmp, right? It is very tiny. Okay. So it is not much bigger device. So coming to the advantages of OpAmp, it is low cost device. It doesn't cost much. So it is a low cost device, like it is easily available in the market also. So it is low cost device. Next, it is small in size. If you just look at the size of this OpAmp in the previous slide, it is very tiny, right? Like you can see it, it is very tiny. So it is a very tiny device. It is around 1 centimeter cross 1 centimeter maximum it will be, like, but it is still lesser than that. So it is very small in size. It is versatile. Versatile in the sense it has large number of applications. You can use this as a inverting amplifier, non-inverting amplifier, differential amplifier, comparator, Smith trigger. Oh, it has lot of applications. So it is versatile. Next, it is flexible. So you can operate with different levels of voltage. Whatever the operating voltages and whatever the operating frequency we have, for all the operating frequencies and for all the operating voltages, you can use this OpAmp. Okay, with certain minimum amount of limitation, you can use it. So it is also flexible. Next is applications of OpAmp. What are all the applications of OpAmp? So if you look at this OpAmp carefully, once you understand this OpAmp, like if you understand what is its application, how its functionality, you can say it is an integral part of almost every electronic device. Like whatever the electronic device you have, every electronic device requires OpAmp. Okay, so it is one of the majorly used device in electronics. So wherever you have analog signal processing and analog filtering, there you will use this OpAmp. What is signal processing? Signal processing means you are manipulating the signal. That is, you start changing the signals. You will add some signal, you will multiply some signal, you will divide some signal. Such are called analog signal processing. So that is signal processing. If you use any analog signal for processing, then it is analog signal processing. Analog filtering. Filtering means removal of unwanted frequencies. Unwanted frequency. So if you don't want certain frequency, you're going to remove it, right? That is analog filtering. Next, mathematical operations, especially for addition of signals, multiplications of signals, integration of signal, differentiation of signal. Okay, so there are a lot of application even in the field of mathematical operation of signals. Next is process of control, communication, computers, power, signal, display, measurements, lot. And next one is used in linear application like voltage follower, differential amplifier, inverting amplifier, non-inverting amplifier, etc. So if you go on studying this OpAmp, it is completely a one full syllabus. So you have the same, if you are going to take the electronics stream, you will be studying about this OpAmp in your next part of your semesters as a complete subject. Okay, it is not just a simple module or a one module explanation. You have lot of things to study on it. So it has lot way more applications on it. Okay. Next is pin configuration of OpAmp. Okay. So pin configuration of OpAmp I have discussed in the previous slide also. It is first one is offset null, next is inverting, non-inverting, power. So this is VEE. Okay, this is VEE and this is VCC. Okay, this is VCC. This is the output pin. This is offset null. Okay, so 8th pin is not connected. If I want to write the OpAmp, you have these pins like this, right? This is the symbol of OpAmp. Always you should connect OpAmp with five lines, that is 5 pins. The first one is, this one is minus, which is pin number 2, that is inverting terminal. This is plus, which is non-inverting terminal, pin number 3 it is. Okay, this is pin number 7, which is given to plus VCC. Okay, and this is minus VEE, and this is pin number 4, right? This is pin number 4, and this is the output pin 6. Okay, this is the output pin 6. So these are all the pin configurations, and this is how it is connected to the OpAmp. Next, coming to the very important thing, which is ideal characteristic of OpAmp. So what is the ideal characteristic of OpAmp? What are these and how do we define them? This is a very important question. They'll ask you this in the examination. So for 7 marks. So you can easily score, because remembering this is also very easy. Next is ideal characteristic of OpAmp. Now, the very first one is infinite voltage gain. Here, what is the meaning of gain? Gain is nothing but V naught by Vi. Here, Vi is V2 minus V1. That is, you have two inputs, right? V2 and V1. I told you we have to take the differential input, difference of the input. So, it is V2 minus V1, V naught. V naught is the output. Now, when I tell that infinite voltage gain, it means that the output must be very large. Even if the difference is 0, if V2 minus V1 is equal to 0, you should have the output as very large amount. That is, it should be infinite. So the gain will be infinite. The gain will be infinite. What type of gain it is? It is a open loop gain. It is a open loop gain. That is, when you don't have any feedback, then you call it as open loop gain. What is feedback? What is open loop? This we will discuss in the further classes. Okay. Next is infinite impedance. Impedance. So what is impedance? Impedance is the opposition force offered by the device for the flow of current, right? So impedance, you should have infinite impedance. You should have large amount of impedance. You can't have smaller impedances. You should have large amount of impedance, and therefore this defines as ideal characteristic. That is, it should have larger impedance, like it should be infinite. If it is infinite, then it is ideal characteristic. Next is zero output impedance. So our impedance offered at the output pin. So if you consider this as your OpAmp and this your output pin, at pin number 6, the offered output impedance should be equal to 0. It should be equal to 0. So that is what output impedance means. Next is zero offset voltage. So offset voltage, it is the small output voltage present at the output. So if you make V1 and V2 both equal to 0, there will be a small amount of voltage here. Okay, very minute amount of voltage. So this offset voltage must be equal to 0. So this should be equal to 0. That is, when you don't give any input, if you don't give any sort of inputs here, still you will be getting this voltage. That is your offset voltage. So this offset voltage value should be equal to 0. That is what zero offset voltage means. Okay. The next one is slew rate. Slew rate. What is slew rate? Slew rate is, suppose you have the output voltage that is changing like this. Okay. So you have a smooth output here, like you have smooth changes here. Okay. Suppose your output is changing at very large point like this. This now the output is changing at very large extent, right? So for small amount of input time, that is for very small amount of time, you have a large change in the output. So this change should be infinite. That is, your device should be capable of changing its value within no time. It should change its value from 0 to infinity and infinity to 0. Suppose you have a square pulse like this. Okay. So look at this pulse. It has high value here and low value here. Within no time it has to switch down, right? It should not take some time. If it takes some time, your square wave will be like this, right? So this is not a square wave. This is wrong. This is correct. So if slew rate is high, you can get perfect waves like this. Like the steep won't be there. Sorry, like the slope won't be there. You'll be having a steep jump. Okay. Next, no effect of temperature. No effect of temperature means even though if you operate the device at extreme temperatures, it should not vary its output. It should not vary its output. So that is the meaning of no effect of temperature. Next is 0 PSRR. PSRR is power supply rejection ratio. It means that so PSRR for an ideal op-amp should be equal to 0. So what is this PSRR? So this I'm going to teach you in the next classes in detail. The next one is infinite bandwidth. What is the meaning of bandwidth? Bandwidth is the difference between two frequencies. Bandwidth is the difference between two frequencies. So infinite bandwidth means, so infinite bandwidth indicates that op-amp should be able to operate all the range of frequency, like the range of frequency. It can operate from 1 hertz, say 1 hertz to 1 million hertz or even more than that. Whatever the frequency you give, for every frequency the op-amp should operate. Only then it is called ideal op-amp. Next is CMRR. What is CMRR? I'll expand it. It is common mode rejection ratio. It is common mode rejection ratio. The common mode rejection ratio should be infinite. What is the meaning of common mode rejection ratio and how it is defined? That I'll be teaching you in the next classes. So I have 2 points to discuss. One is PSRR, the other one is CMRR. Okay, that we will see it in the upcoming classes. Now, next is operation of an op-amp. What is an op-amp? You studied like what is an op-amp and what are all the different pins you are having. So, how do you, what are its applications like, and few of the major important points you studied, that is about its characteristic. Now, let us see the basic working, very basic working. So, I don't go for the advanced working here. I'll just give very basic working here. Okay. So, the first one is you are giving an input here. You have an op-amp. This is the op-amp and you are getting an output. This is your input signal. This is the op-amp and you are taking the output. Now, where are you giving this input? You are giving the input to pin number 2. What is this pin number? It is 2 because you have minus here, right? So minus, I said it is inverting input. What is it? It is inverting input. And this is plus. Non-inverting input is grounded. It is grounded. I have grounded it. Grounded in the sense you are giving that to ground connection. Fine. Okay. Next is you are taking the output at pin number 6. This is the output you are getting. This pin number 7 and this is pin number 4. These two pins are given to power supply. They are given to power supply. Power supply, say for example, I am giving to plus 12 volts. Here I am giving minus 12 volts. Okay. Now, you are giving an input signal with an amplitude Vm I will take. Vm I will take. And you are getting an output signal with an amplitude naught. Okay, V naught. Now, what is the relation between input and output with respect to this OpAmp? First thing, you are giving the input to inverting terminal. That means your signal, sinusoidal signal, that is plus sine theta, becomes minus sine theta. Can you see this? It is inverted, right? First you are getting the negative half, then positive half. Here you have positive half and here you have negative half. Here you have negative half and then positive half. This is what inversion means. First you will get, like, whatever the signal you give, for that it becomes minus of the signal. Plus sign, minus sign. Okay. So because you are giving the input to negative terminal, that is inverting terminal, it became inverting here. It became inverted here. Now, what happens to the output? I told you output is the difference of the input and it is amplified, right? So output is the difference of the input, like whatever the input you give, we will take the difference and then it is amplified. Then it is amplified. So now I'll take V naught. This is V naught, right? V naught is equal to A. What is A? A is the amplification factor. A is the amplification factor without any feedback. Can you see any feedback here? Is there any feedback like this? No, you don't have any feedback. So, without the feedback, whatever the gain you get, that is your amplification factor. That is the amplification factor A into V2 minus V1. Why are you taking V2 first? Because it is given to the positive terminal, which is non-inverting. Then you are taking inverting terminal, which is minus V1. Okay. What is the value of V2? V2 is grounded here, right? You are grounding here. So voltage given to this is 0. Voltage given to that is 0. Minus V1 is equal to minus A into V1. Correct? That is, you will be having a negative gain of A times into V1. For practical example or to understand it, I will give you an example. Like, let me take this voltage peak is 1 volt. This is 1 volt. And amplification factor A is equal to 5. It is equal to 5. If it is equal to 5, then V naught will be equal to 1 into 5. What is 1 into 5? 5 volts. It is again 5 volts. So, because you are having minus here, you will get minus 5 volts. See here, when you have plus 1 volt, you will be having minus 5 volt. When you have minus 1 volt, you are having plus 5 volts. So, that is what the negative sign indicates. The negative sign here can also be called as phase shift. Can also be called as phase shift. So, the phase. So, here you have a positive phase. Here you have a negative phase. You have a phase shift here. Okay. What is the phase shift here? If you have minus, it is 180 degree. It is 180 degrees. You have a phase shift of 180 degree for this operational amplifier that works in inverted mode. That works in inverted mode. Hope you understood. Okay. Next is operational amplifier working in non-inverting mode. So in the previous case, V2 was grounded. In this case, V1 is grounded. V1 is pin number 2, V2 is pin number 3, and the output is given at pin number 6. This is pin number 7. This is pin number 4. This is pin number 7. This is pin number 4. So it is given to plus VCC. This is given to minus VCC. So V1 is given to ground. V2 is given with the signal. V2 is given with the signal. And this is your output. This is the output. Now look at this. You are giving the input to positive terminal. Therefore, you don't have any phase shift here. You don't have any phase shift. See, if you are giving sine wave, you are getting the same sine wave. There is no inversion. So V0 can be defined as A into V2 minus V1. What is V2? It is the sine wave, that is V2. V1 is 0. So V1 I'll take it as 0. In the next step you have taken as 0. Here V2 you will retain as it is. So A into V2. As usual, A is the gain, open loop gain. So V0 is equal to A into V2. So the output will be amplified A times than the input. Okay. So if I take the same example, if the amplitude is 1 volt and here it is minus 1 volt, then I'll take the value of A as 5. I'll take the value of A as 5 here. Then the output will be, here it will be plus 5 volts and here it will be minus 5 volts. Okay, this is plus 5 volts and here it is minus 5 volts. This is the operation of OpAmp. Okay, so that's all for the day. Thank you very much. If you have any questions, you can post me into the mail ID what I have given. Okay, or you can message me. Thank you. Let us meet in the next class.